Chris, could you mute? Hello, everyone. Welcome to Space Influencers. My name is Azita Noruzi, and I'll be your host for this evening. We're joined by our speakers, which I will introduce you now, and we'll tell you a little bit more about what is going on here, which we are currently we are talking about the making of Delfi-C3 and celebrating it. It's over 12 years being sent out into orbit. So now we are joined by our speakers. First up is Chris Verhoeven, IR Dr. Chris Verhoeven. Hello, welcome. He is associate professor at TU Delft. He's also responsible for design and implementation of the electronics of Delfi-C3. He's also the theme leader of Swarm Robotics at TU Delft Robotic Institute and Space Robotics at TU Delft Space Institute. He's also the project director of Lunar Zebra project at TU Delft. Welcome.
Thank you.
Next up, we have Mr. Wouter Wegelaar. He's the RF engineer at IC Space, and he does constructing the nanosatellites and CubeSats. My apologies, CubeSats. He did his bachelor degrees on Delfi-C3. He's also involved in ground station. Welcome.
Next up, glad to be here.
Glad to have you here. Next up, we have Ms. Alessandra Menicucci. She's assistant professor at Space Systems Engineering, and she's currently the project lead at Delphi PQ and Delphi Space.
Hi, everybody.
Next up, we have I lost the name. Sorry. We have Georgi Khadayev. He's a professor at innovative computer architecture at the University of Groningen, and he was also a professor of computer engineering at TU Delft. He was responsible for design and implementation of embedded software of Delfi-C3. Welcome.
Thank you. I'm glad to be here. And actually, you forgot to say that after so many years, the satellite is still operational.
Yes, we're getting to that. Next up, we have Mr. Stefano Spreta. He's the assistant professor at Space Systems Engineering at TU Delft. He's the communications engineer and a team member of Delphi Pocket Q.
Hello.
Welcome.
Thank you very much for inviting me here.
And last but not least is Jillian Audubon. She is one of the members of Space Influencers, and she's a student from aerospace engineering at TU Delft. And she's also the chief engineer at Lunar Zebra. Welcome.
Yes, thank you, Azita.
Thank you. Now, Jillian, could you be so kind and present us with a PowerPoint presentation about Delfi-C3?
About Spacefluencers, I'm going to give a quick introduction before we begin. Okay, the screen is visible. So yeah, thank you, Azita, for the introduction, and welcome to everyone tonight. I'm Jillian. I'm from Spacefluencers. We're the group that organized this event tonight, and I'd like to welcome you all and thank you for being here, and also thank you to all of our speakers, and thank you to Azita for hosting. Before we begin with the making of Delfi-C3 event, I'm gonna give you guys a quick look into what Spacefluencers is, who we are, and what our goals are. So as you can see here, our main aim is to influence the future of space. But first, who are we? Here you can see us. This is our core team that we're starting out with. Here we're enjoying some milkshakes before the whole pandemic lockdown happened. From left to right, we have Xavier, Alexander, myself, Ramon, Chiara, and Manish. And we come from a wide variety of backgrounds. We have entrepreneurs, lobbyists, engineers, cake bakers, event planners, you name it. And we're all united by our common goal of demystifying the space industry for all. So, how do we do that? um, we have an online community, and that's a place where we connect young space professionals, students, space enthusiasts in general, with people from the space industry, so leaders and experts. But the community is also for anyone who's just interested in space and maybe doesn't know a lot about it as yet, but would like to. So, yeah, our mission is to connect young space professionals with new space industry leaders, but also to encourage collaboration between the space industry with different sectors, which is happening more and more. And our vision is to bring awareness to this new space industry and how it's rapidly growing and what opportunities there are in there, but also to make space knowledge more accessible and understandable for people who don't really know much about it as yet. So, what do we do? We've had a few events so far. We've just started out, and our first events were for the World Space Week in the Netherlands specifically. We planned the events for at the World Summit AI. We had a few different panels. The first one was the New Space panel, more about the space industry. We had one about space education and youth participation. We also had one about SDG 18, Space for All, specifically to inspire children through space and science. And lastly, we had one about cultivating partnerships in the pandemic paradigm. And here you can already see kind of the topics that we touch upon, not just space industry related, but also how it can flow out into other fields. And what will we do in the future? We're going to continue to host some online events like these while the situation is still the way it is. And we also hope to get some partners on board to be able to collaborate with them and host partnership events. We'll also start planning the World Space Week for next year. Fingers crossed it can be held in real life as usual. And yeah, continue working on SDG 18, which is Space for All, where we aim to get space on the UN's agenda and thus the global agenda. We also want to get some ambassadors on board that can help us out with, yeah, spreading our message, and then have some events with them as well. And mainly, we're going to set up some action groups revolving around the topics that I already mentioned. And that's a place where our community members can get even more involved if they would like to. And topics would be education, entrepreneurship, politics, and things like that. So if this sounds interesting to you and you would like to learn more, then you can follow us on spacefluencers.com. We have a lot more information, and you can also join our community and connect with over 100 people who are already there. It's on Discord, and you can join at community.spacefluencers.com. And you can also follow us on our social media. We're on Instagram and LinkedIn so far. We're going to get on Twitter soon. And since you're already on our YouTube channel, you can also subscribe to stay informed about more events like these. And yeah, thank you for being here. I hope you guys enjoy the event. So let's continue.
Perfect. Thank you so much, Jillian, for this amazing introduction about space influencers. And I hope many more students and young adults will join in and would want to participate with space influencers.
Yes, and I also just wanted to remind the audience, if you have any questions for our speakers, you can drop them in the chat on YouTube. And at the end of the session, we'll have some Q&A, and then we'll ask the speakers your questions.
Perfect. So let's just start with the whole thing and go talk about Delfi-C3 and the history behind it, how it all started, and what just brought it up. Someone who would like to start?
Yeah, well, what brought it up was actually a flyer that Barry Zandbergen brought from a conference. And he said that it was possible to buy a CubeSat kit. And with that, you could build a real satellite and maybe get it launched. And there were already plans at the Faculty of Aerospace and Engineering to do something like that, but it was a big satellite of which it was not realistic to launch it. But the CubeSat that was actually something that was realistic. So I asked for some money, and you can see in my little video, you can see an aluminium box over there, and that is what came with the CubeSat kit. So nobody knows where the box is at the moment. So it's somewhere at the university. But this is what it started. So it was just an aluminium box, but also a real true CubeSat with you see the switch for the kill switch for the deployment, beautifully built, and we put it on the table. And when you put something really on the table, some hardware, then it exists. So from the day that we had this thing, we had a satellite and we started working on it. So yeah, and then you get enthusiastic students that want to work, and we were very lucky to have a group of enthusiastic students. So here is a start of the team. It's not the complete team because there were a lot of them, and also a lot of them were busy. But if you if you look at the list and on the right, you see Jeroen Rotteveel, and later, well, he became the director of ISIS Space. And next to him is Eddie van Breukelen. He did finances, but in the end he started doing something else. And next to him is Abe Bonnema, and well, he is still doing the. I think he does the most of the traveling. Stefano, you've seen him more recent. So what does Abe do?
Well, Abe is basically the responsible for launches. ISIS lives also on launching spacecrafts, and he's basically the face of the launch business at ISIS.
Yeah, I remember that even when we were building Delfi-C3, Abe was a good negotiator and system engineer. I can remember that at some point we were extremely stressed because the electronics didn't want to do what we wanted it to do, and the time for the launch came closer. So yeah, we got quite stressed, and you get tension in the team. And then Abe would come and say, "Well, let's have a beer at the Beestermarkt in Delft." And yeah, that solved the problems. So and then we could go on. So he did a very good job at it. And if you look at the back in the middle, there you see with the white shirt Wouter Jan Ubbels. And he was the first aerospace engineering student I ever met. So Wim Jonkind was at that moment leading the group at SSA. And he had a student doing something with radio and receiving satellites. And he asked me if I could help supervising Wouter Jan. Yeah, Wouter Jan is a radio amateur that when you meet him, he really infects you with the virus and with receiving the satellites. So we in no time we were both on the roof of the AV building with a dish on a chair and an antenna trying to communicate with Oscar 40, and then you got infected. And I think he is responsible for a lot of enthusiasm to actually go for building the satellite, go for the electronics.
Oh wow!
Yeah, and then every student you see over there has a story. We have the antennas that are made of measurement tape, and they were built by the student next to Abe. And when he graduated, I remember he wanted to start a camping. So I don't know what came from it, but we have all different kind of things we did. But if you really want to know who worked on Delphi, who are important for it, you actually would have to have a look inside of Delphi. And because what Rob Haman did, and he was one of the staff members in the team, he put all the names of all the people that contributed to Delphi in the satellite. So all the names are in space, and he took a picture of it. So this is a picture. And well, if you look at that picture, then you see all the people that contributed to building the satellite. Yeah, and then yeah, we started working day and night to build it. I remember about Wegelaar probably also. We were in the middle of pizza boxes in the night trying to get the radios working. that we were in the middle of pizza boxes from the picture from Wouter. At that moment, you wouldn't say. They probably didn't eat them. Had no time.
Yeah. Yes.
But yeah, it was a really great time. I really think back of it as something really great. There's also on the picture still a master student over there of Georgie, Gerard. Yeah, in the black shirt.
Yeah, the Gerard, of course.
Yeah, maybe you can tell something about Gerard.
Yes. I was hoping to meet him here. I didn't talk to him for a few years now. I'm following what he's doing at ISIS in space, and he is indeed doing great job. So at some point, indeed, Wim and Chris approached me as well and said, "Look, we have these CubeSats, and they're very nice. However, we have to figure out how to program them." And then I start looking around for some students in the computer engineering program. We just started it a few years earlier in Delft, and we had bright kids. So I think that in total, something like 4 or 5 students graduated with me, helping with different parts of the system, and not only Delfi-C3, but also trying to do some of the studies for Delphi Next. And Gerard was one of them, and Gerard liked the work on the Delfi-C3 so much that he also was one of the key founders of ISIS in Space, and I'm sure that Wouter can say more about that. And yeah, it went so good that unfortunately, I must say, I don't think never graduated from the TU Delft. So he had everything done, but he had to complete the thesis and defend the thesis. So maybe at some point we'll do it. Who knows?
He can still do it as long as we are there.
Exactly. I'm still here, and I still have signed off his degree, and of course, I have to talk to him about this. No, but he's really working very hard, and I'm sure that he contributed a lot, definitely for Delfi-C3, but also for the activities of the ISIS in space. And as I said, so maybe Wouter can say a few more things about Gerard. And I'm really sorry that I didn't push a lot of pressure and really go and chase him every day in order to graduate. But I'm sure that even without having the official engineer's title from TU Delft, he's doing more excellent work than
by work he is an engineer.
any average engineer that you can meet that graduated from our university.
Yeah, this holds for a lot of people that started in the early days, including myself as well. When we started the company, there was just so much to do on the company side that you were like, oh yeah, that thesis, yeah, later. And in case of Gerard, it's still later. So yeah, but he's still working on flight software in our company, and yeah, very much also supervising other people in coding. Yeah, several software things in our embedded software department. And yeah, one of the long-standing employees in the company.
But we also had people working in the team that later started their own company in rocketry, like we had Erik Smit, one of the radio and ground station people. So he came to do an electrical engineering assignment and asked, do you want to work on a radio? And he did. He got infected. And then I noticed that in DARE, which is the organization that launches rockets, one of the important causes for failure was the electronics. And I thought, that's just not possible. So I asked Erik, can you also have a look over there? And he did, and he became the first electrical engineer that was part of DARE, and that gave him quite a boost. And in the end, there were more electrical engineers there. And then together with some other people from there, he started his own company in rocketry. So a few years ago, I met his parents, and they said to me, It's so strange. We had a son, and he studied electrical engineering, and we thought, oh well, he's going for an electrical engineering company, and now he owns a company that builds rockets. So if you look at that, the Delfi-C3 changed a lot of lives.
So when did it all started? Because it was it kind of feels like it's the pioneer for the next projects that came up. So for Delphi Next or for Delphi Pocket Cube. So what was the timeline? When did it all began? When was it launched and where?
I think when you go really to the beginning, then there was a person, Wim Jonkind, and he started working at aerospace engineering. And he was very good in bringing people together and letting people cooperate. To do a big space project, it was absolutely necessary that two faculties, electrical engineering and aerospace engineering, would start working together. And electrical engineering had big projects, like I was in the years before. I was in a project called Ubicon. And a very short summary of what this project was is we were building Google Glasses. So we had basically all technology there, and despite all the money and the work, we never managed to build even a good demonstrator. And later I learned it was due to lack of systems engineering. We just didn't know how to put the whole thing together. And that was also basically because we as electrical engineers thought that systems engineering was boring, useless, extra work that nobody needed. So we had a million reasons why we would not do that. But then when we were dragged into the space business by Wim Jonkind, yeah, we gradually learned that it was important to do so. And at aerospace engineering, they learned that if you want to do the expert electronics and so on, and the expert computer engineering, you need really to go to the experts, to the other faculties. So the two faculties together managed to do this. I don't think that either one of the faculties could have managed to get it working, but in the cooperation it worked. And Wim just crossed borders. For him, there were no, I think, no faculty borders. He just walked in between everywhere. So the equipment was shared, people were shared, walking in and out each other's labs. And of course, very stimulating thing. We were really building something that would go to space. And that is, a boys and girls dream, you could say, in building something of which you actually know it is in space.
I think that's
Yes, sir. Stop.
sorry, I wanted to say, I think that is a really important distinction. TU Delft has had, before Delfi-C3, a lot of other space projects, satellite building, but they've all been paper projects. So you create something, or you write a thesis, and in theory it should work, but it's never launched. And Delfi-C3 was the first time where we just said, like, great, such a paper project, but let's actually do it. Let's launch this thing, and let's really create a satellite, because we've gone through a few satellites in the past in engineering, which are usually either donated parts by industry or taking apart something that already existed to see how it works, but never really a satellite where you say, okay, let's design this, construct it, and actually launch it and operate it.
Yeah, of which you actually could believe that it would go to space. And here for us, it was very important. There were sometimes people that said, yeah, if it doesn't go to space, then still it was a good educational project. And we all said, nah, if it isn't not going to space, we'll stop right now and do something else. If not going to space would be a disastrous failure for us. But fortunately, it went there. But there was, of course, a lot of help. So also help in the sense of the university helping. So at aerospace engineering, there was a dean, Ben Droste, and he was a guy that at some point he said, yeah, well, now we built it, now we're going to launch it too. So once he thought it was a good idea, then that was final. We all liked working for him, if you mention it like that. He as a dean could actually come to the lab, and then he knew our names, and then he was asking how is it going. And of course he was an Air Force general before, so maybe he knew how to work like that. And then he could say something like, continue, man, and then he would go on, and then we would keep working. But he knew how to keep us going and support us. So we were very lucky to have people like Wim Jonk in there, Rob Hamann, of course. Without him, the satellite also would not have been built and flown. He was a very patient system engineer, and maybe people that hear that are surprised, but he knew how to deal with the electrical engineers that didn't believe in system engineering. So he and he managed that, and he got us doing that. So that is a huge achievement.
So we have a question from someone from on YouTube. Jason is asking that how long from the start till the launch did the project take?
Yeah, maybe the dreaming started in 2002. And I think
the
it was
one?
and then say around 2006 we were serious in saying it's going to space. Then we were sure that we could pull it off. So a lot of dreaming went before that, listening to satellites, working with satellites, starting to build the ground station.
Yeah, that was 2005, I believe, and launch was in 2008 for good measure. So yeah,
I have a lot of pictures where we state that it's going to fly in 2006, but we didn't manage that. But in 2008, it finally went.
I think we probably have pictures for each individual month between that date and actual launch.
And now it's really it started becoming a joke. You know the story about the satellite that went to space? Well, it didn't.
There's a quite common joke in the aerospace industry where they say when it's going to get launched, and people say, "Oh, before Christmas," and then the next answer is always, "Which year?"
So the development process, there were obviously some challenges there. What were the biggest challenges that you faced during making the Delfi-C3?
Uncertainty was a lot. So we were building something of which there was little heritage. So we didn't know, is this going to work? Is that going to work? But there was one thing, I think the decision was by Rob Hamann, or at least by that expert team, that we thought we are not going to fly a battery. We looked at failure modes of present CubeSats, and by far on number one was failure of the battery. So we thought we should build a satellite without a battery. Maybe that's the reason why it lived so long. So we didn't have to worry about the battery anymore. Yeah, and then we had lots of minor challenges. Say what works and what does not work. And then we started building radios like you see in my picture now. Maybe you recognize some parts of it, Wouter?
Yeah, I do. I might still have some of those parts.
Yeah, these come from a box in my office, but there's much more.
I don't have these parts.
I think your sound is gone, Wouter.
Yeah, could be.
You did the self mute, yeah.
Yeah, I see a PA on the bottom left and some mixer modulator on the bottom right. Anyway, that's all technical stuff. I also see the names of some of the people that worked on these. Yeah, this was probably around 2006 or 7 that we built hardware like that.
Yeah, so it was testing. Trying to understand it, and of course keeping things simple, eh?
Yeah, I that's one of the memories that I also have of you, Chris, in the lab, always running around with, "Oh, this sounds complicated. It has to be simpler." One of the lessons that I also learned during development is, if it looks really complicated, it's probably not the right solution.
Yeah. Wrong things are complicated. Simple things are correct.
So you made this, and now that there's well, there's Pocket Cube that is happening, that they're working on that one. Before that, it was Delphi Next. So what do you think was the motivation? What motivated for the Delphi Pocket Cube that to build another version, another thing, uh, another project for this?
Well, CubeSat were a revolution in terms of miniaturization of spacecrafts. At the time, I was not working for TU Delft, unfortunately. I was at ESA, and I remember that we were looking at CubeSats with a lot of curiosity, but also, yeah, we were not really believing in these things because they were too small to be launched. And so everybody at ESA was making a little bit of fun of this university that were launching CubeSats. But at the end, now ESA is really investing a lot of resources in developing their own CubeSat. So it's becoming a mainstream for the big agencies, for commercial companies, because CubeSat demonstrated that miniaturization has a lot of advantages, of course. It's not only yeah, the cost, but you can really do a lot of nice additional things with the CubeSats. So miniaturization is a trend that is going on in space industry since many years, and CubeSat are one example of that. And so after the success of Delfi-C3 and Delphi Next, in our group, we thought, okay, how can we really advance the miniaturization of satellites? How can we go further? And we looked around, and very promising form factor was the Pocket Cube, because it was not completely um, new. So we were not really the inventor of this form factor. Was already existing. So some of the infrastructures that you need to launch a Pocket Cube were developing. And we just embarked on this new adventure, trying to squeeze even further the size of a satellite. A Pocket Cube is composed by cubes, exactly like CubeSats, by that are 10 by 10 by 10 centimeters. So they are extremely small. And yeah, you can really have a very small satellite. Um, and that was basically the main idea. We wanted to stay in the pioneering front of the space industry, of space engineering, sorry. And yeah, it took us some time because it was very challenging. It demonstrated to be more challenging than we thought at the beginning. We also had to face a miniaturized team, because if when I hear about the Delfi-C3 team, I'm a little bit jealous because we didn't have the luxury of all the students that Delfi-C3 enjoyed at the beginning. So we were really miniaturized also in terms of manpower, but we managed to deliver it very not long ago. A couple of weeks ago, it was delivered to the integrator company in Scotland. They shipped it to US and it's going to be launched in December this year. So we are very excited about it.
Wow, that is amazing news. So you just mentioned students that were there for Delphi-C3, and well, there are also students for Delphi Pocket Cube. But how do you get the students involved in this, and how do they get informed about the existence of such project, get invited, and start working and helping out with these projects?
Yeah,
you
well,
know,
you, go ahead, Chris.
yeah. Well, the different things. So with Delfi-C3, I can't remember we tried to get students because they just came and wanted to work on it. So everybody knew they are building a satellite. So from all over the place, also from HBO's, I got students said, "Hey, you are building a satellite. Can I join?" And there was so much to do that we always had something. So people would ask me, can you give me an A4 with assignments? And we said, no, we don't have A4s with assignments. We have a running project. Whoever comes in can immediately start working on something. So it was yeah, a self-driven team. And of course, they would talk to their friends. They would talk to the schools. There was in particular on the Hogeschool Rijswijk that still existed there, that had one teacher over there, how cool. And he specially selected students for me. Then they would come to the university and then he said, Chris, I got some students for you. But there were also students who said, yeah, he wanted to work on the project, but I'm not going to send him to you because he's no good. So he did some checking there. So it was self driven, and of course it was very special building a real satellite. So everybody wanted to be part of it.
Well, Wouter, you were one of those students who did your degree on it, did a project, your thesis. How was it for you as a student perspective to work on such project?
Yeah, for me it was very exciting because I was one of the first students from my school to actually go towards the TU Delft. So I did a bridging course to enter the university. And like Chris said, I remember coming in with an assignment or a question for an assignment, and somebody was like, oh, you could work on this floor and do this thing, and you could work on that floor and do that thing. Oh, and there's also a satellite project on the 18th floor. We don't know a lot about it, but and I was like, satellites? And I made an appointment with Wouter Jan and Chris and basically got sucked into the project. Obviously, when you hear as a student like that you can work on something going to space, you're immediately interested, at least for people interested in the space business. And I was, yeah, immediately thinking like, okay, I'm going to work on hardware that's actually going to space. That's amazing. Also, no clue what that means. But yeah, we were really welcomed by the university. And yeah, it felt like a really great team to work in. I think it is really nice to be in such a closely knit team together. It was very challenging from educational point of view, like doing your courses and then also working on the satellite. I was doing two things at the same time. My recommendation to people would be don't. But yeah, I don't regret a single minute of the Delfi-C3 project. It was really, really amazing.
Yeah, and we had to fight the battle against the radio amateurs. I know you are one, but with the Butler oscillator that I didn't want to use.
I recently found my timesheets back because I was keeping track of time during my thesis. And I can see that the first 4 or 5 weeks I was just on the wrong track. And looking back at that right now, it's so obvious. But then it was like working for 5 weeks and then Chris just coming and saying like, I don't think this is the right way to do it. And I was like, are you sure about that? And he was like, yes, I have a better solution. Turns out that was true. Listen to your professors, I would say. But yes, that was interesting.
Yeah, the Butler oscillator was a quite complex oscillator to make an overtone crystal working. And I remember I said to you, there's not for nothing that there's the word "but" in the name of the oscillator. Don't use it. And the other one now, the other ones, 4 of them, they are working perfectly fine now, still for 12.5 years. So there must have been something good in your design.
Was also used in. Yes. Yeah, that design was also in other satellites, and one of them was is in FunCube, and FunCube is a 1-unit CubeSat that has been launched in 2013, and is also still working. So that design definitely is very nice, and it behaves, which is good.
Yeah. Yeah, it can hardly make errors.
Well, that's fantastic. And what about for Pocket Cube? How are the students involved or get involved in that project?
Well, of course, there are these days many ways to advertise projects at the faculty. So we do have our social media, we have the Twitter, but the best way is always, when we give a lecture. When I give a lecture, there are always students that come to me and say, oh, okay, or to other staff members, to Stefano, for example, and they ask, do you guys have a cool project to work on? Because we really want to work with the hardware, and these are the ones that are really interested in developing a satellite. But these days, students are very much distracted by many projects. We have different projects, and this is a little bit, it's great, I think, in my opinion, because they've got a lot of choice. But it is, of course, reducing the number of people that work on one thing. And I think that the Delfi-C3 was really special because it was really the first time that a CubeSat was built by a Dutch university. So it was really special, and it attracted a lot of students. But we still have a lot of students that are interested in building something. And launch into space is indeed the thing that makes it so attractive. But I guess, Stefano, you also get a lot of students asking for projects.
Well, now CubeSats are becoming more popular, and now people talk about deep space, and everybody wants to go to deep space. So there's definitely a lot of competition. So in that sense, back in the days, this was the project pooling. Now there's a lot of alternatives, which makes it difficult. Anyway, we still survived. We've been working very hard to get the project going, get all the students involved. This period was, to be fair, quite a mess because besides all the activities, we saw very nice pictures with hardware that the students could build. Basically, in the last year, students actually almost couldn't touch it. So that's also kind of a big shame for students. They couldn't really get there. It was really a pity that they couldn't get to touch the satellite. But yeah, campus has been closed for quite a while. So yeah, it's fairly different. I was involved in projects similar to Delfi-C3 when I was in university or in the years before TU Delft. And yeah, touching something that goes to space is something that motivates a lot. So in the end, once you can't really get their hands on it, the motivation gets difficult it's really difficult to motivate people.
Wear gloves when you touch it.
Damn it, that's a good suggestion. No, I wanted my fingerprints to remain. That's sort of how do I leave my mark?
Yeah, I remember that a lot of other people did not want the fingerprints to remain.
Nice picture with a fingerprint. Okay, now can we find out who is that fingerprint?
Yeah, I can remember when we did a deployment test of the antennas of Delfi-C3, that after say a few days or weeks, I forgot, of storage, they didn't come out, and then it happened also that the fat of the fingers actually glued the antennas. So then we started to learn that we needed more discipline in that sense. So that's also when we started thinking about a clean room. And the clean room is not so much a clean room like you have in microelectronics to keep the dust out and make good chips, but it's more to keep the pizzas and the fat fingers out.
Well, that cleaner is still up and running right now, despite the years. We still have it. We still run projects in the clean room, and it's definitely heritage from Delfi-C3.
Yeah, it's like the ground station is also up and running and bigger and better. And it's also started from Delfi-C3. So a lot of facilities that were built to have Delfi-C3 survived Delfi-C3, the project, because Delphi is also still there. But yeah, a lot of extra research came from it.
Yeah, that's correct. And of course, this makes a lot of sense. But Stefano, maybe you can tell us how much of the original design is reused in the current project? Is there something that is reused, or you are designing everything from scratch? How this part works?
Well, we started looking at what was done in the past when we started the project, but the big issue is, well, Delphi PQ is 1/2 the size in every dimension. So basically 1/8 of the volume. The big issue we faced was that, yeah, nothing would fit in such a system. So most of the design is actually from scratch. And we really had to look for small components. Well, of course, now mobile phones, everything has to be super small. And we really had to push to be able to fit similar functionalities, similar level of functionalities in a volume which is 1/8. So yeah, not so much heritage actually remain? Well, we have a battery. That's the biggest difference. Fingers crossed, by the way.
Yes, but remember what we decided with Delfi-C3 to not have a battery, and this makes actually this made the task of the embedded software quite challenging because you never knew at which phase of execution the power will be gone. So basically, this intermittent way of operating is built in the software, and really, once the power is lost, and after the some half circle of the orbit, the satellite will be powered by the sun again. The software will continue right from the state, right from the moment where it was interrupted. And this was one of the important functionalities in that software. So I was hoping that you also decided to not have a battery and reuse maybe some of that.
No, we're very good at making our life complicated. That's engineers. Well, as Chris mentioned, make it simple. No, let's try this. Let's try this.
But can it survive? Can it function without battery?
Technically, yes. The idea is the concept is fairly similar. I mean, one of the greatest advantages Delfi-C3 had is that the lack of battery makes it much more immune to radiations, because if something really goes wrong with single event effects, the system might actually be killed and it would be impossible to reset it. And this is one of the big risks we now run. But actually in Delfi-C3, yeah, you just need to wait, worst case 45 minutes, and yeah, your power is gone. So if you can survive, then you're good. So in that sense, that was a bit of an inspiration, trying to make sure we can always shut it down.
Yeah. Some people indeed claim that because Delfi-C3 has a really truly reset every orbit, that is one of the keys for survival. But I must say also, I think it was in 2012, there were enormous solar flares. I can still remember then. I have some SOHO pictures where you can see that SOHO is nuked by it. And then there were problems with power plants and whatever. And but Delfi-C3 was still there. So then I would call Wouter Jan, is it there? Is it there? And I still do the same thing, but now I call Niels. But always listening to it. But it keeps surviving, even if the space is very violent. So.
Well, willingly or unwillingly, well, it has about 3 years to go. Physics actually will have its course and it will re-enter in 3 years. But yeah, it would be nice to see if it still survives till the end.
Yeah. Yeah, that is basically also what Delfi-C3 is at the moment. At the moment, it is a longevity experiment. So if you look, for example, at the thin film solar cells, they are totally gone. So the measurement system still works. So you can see that there is a little bit residue of solar cells there, but they ablated totally. So you could say that experiment is over. But yeah, as long as it lives, you can say EEPROMs can survive in space for now at least 12.5 years.
Well, we demonstrated, a month ago, roughly, that still all the uplink receivers are still operational. This is one of the tasks that we have to do periodically, but basically by law, we need to check if the satellite is alive. And well, both command receivers are still operational.
Yeah, I can remember that at some point a few years ago, with the insurance fees that you have to pay, there were people saying, well, maybe we should shut Delfi-C3 down because of this. And I can remember that that caused some agitation in our Delfi-C3 community. And I think it was with one of the Wouters, you or Wouter Weffelaar or Wouter Jan Ubbels, that we said, let's just break the ground station, just nuke the transmitter, because they are not going to kill Delphi.
Yeah, I definitely remember that discussion. Yes, we didn't want it to be turned off. And I think at this stage, we're just interested in when it will, how long it will last. It's a monument in space at the moment. And we can just let it do its thing and just keep watching it and not turn it off.
And the only thing I've seen in the telemetry is that right after launch, the onboard computer was using about 3.5 milliamps, something like that, and now it's 30. But it can never be 30 and be fully functional. So probably one of the op amps doing the measurement has got an offset.
Yeah, or one of the reference voltages, one of
Yeah,
the band
something
gaps
something
or
like
something
that,
like that.
went away, but it can't
Well,
be that the processor uses 10 times more power and
And nothing else goes wrong. Yeah.
yeah.
well, that case that you mentioned is actually quite cool because what was 2 years ago, a year ago, there was the summer space program of the International Space University in Delft, and actually Delfi-C3 was used as a sort of guinea pig to show students
Yeah.
how does a CubeSat look like. Good, we had the spare model in the classroom with all the students looking at it. One of the cool things we did was actually turn on the radio. Well, the satellite started working. They could look at the telemetry, and it was the satellite on the table transmitting. 3 hours later, satellite was turned off. We all move into the ground station and start listening to the real one. Actually, a bunch of students asked the exact same thing Chris just mentioned. Hey, why does the onboard computer consumes more? Yeah, this guy has been 12 years in space.
Yeah.
So that was something that for them was like, oh, really?
Yes.
Yeah.
Yes, but
This. Go on, Chris.
no, you go on.
I was going to say this is one of those things where you really see the engineers at work, where you find out that people want to know and they want to fundamentally understand what's happening. Like often there's people that say, yeah, that's just a number. We don't care. But engineers want to know, like, why is it doing that? Is it dangerous? Do we know why it happened? And there's all kinds of theories. But it is interesting because it's in space, so it's sort of a forensic thing. You can't just go there and say like, oh, let's just take a voltmeter and poke it. We have to really figure it out from all the evidence that we have on the ground, which is also really fun. I think from an educational point of view, but also as a project team, launch was definitely not the end of the project. For some people it was, but for us it has always been a learning experience, and it still is, because we still see things happening that are strange, or we can explain it, but yeah, you can just look at the telemetry. It's amazing that it's basically just working.
Yeah, and also this one receiver and the transponder what is the cause for the failure is the adventure of tracing it back. That we heard the noise of the AGC, so we knew from the AGC to the transmitter the transponder is working. And then I remember with Wouter Jan Ubbels, we put 400 watts in the transponder on one side and a signal, and it came converted out at the other side. So the oscillators were working. So we had some more damping, and then I remember that a radio amateur said that the transponder was functioning intermittent, and that was then it sounded like something had cracked. But the strange thing is that it happened for one radio, and the other radio is exactly the same, and it doesn't have it. So I really would have liked to have Delfi-C3 back on the table.
Yes.
So that's why I had one design synthesis exercise at aerospace engineering when I was still working there. That was called the Return of the Queen, where I actually asked the students to build a system that would bring Delfi-C3 back. And I think the design was so good that if you would have enough money, we could get it back.
That's correct. But see, about telemetry, there is a question. So there was a novel solar panel that the Delfi-C3 was basically measuring its parameters in space. And the very cool part of it is how to get this telemetry down to the ground station or to the central place of the university. And we use the network of the radio amateurs. And this was actually my question to Wouter. Are the radio amateurs still using the Delfi-C3 to establish connections?
Yes. So as Chris already mentioned, the transponder has had a failure on board. I've also been looking at the chat a bit. So I'm gonna group a couple of questions, because one of the questions was, for how long did we design the satellite to work? Because that's also an important input. So 1 year was the design goal, of which maybe 3 months of science, and then for the rest it would be turned to transponder mode, so radio amateurs could actually use it to talk to each other. And in the end, it has tremendously exceeded the lifetime. However, in this extended period, unfortunately, the transponder has gotten into some trouble that would make it less usable. But it's still sending the data back of all the experiments on board. We have a wireless sun sensor on board. And I also saw one of the people that was involved with that, Johan, in the chat. So good evening to Johan. He is asking, is that sensor still working? As far as we are aware, yes, it is still working, but we're not getting all the data all the time. And that has to do also with this software startup procedure that every time that it goes on, it needs to boot properly, do all the things. The other experiments were solar panel, thin film solar cells on the satellite. Those have degraded a lot, but that was expected. That was part of the experiment. So we wanted to see how they degraded. And by now we still get measurements from those cells, but the cells themselves have really degraded quite a lot. But yes, radio amateurs are still sending us those data points daily, and we are still getting more and more data to analyze. So we can still see experiment data, but we can also treat all the other data as an experiment. So all the things that we know about, are the temperatures increasing? Are the currents increasing? Are there other things on board that are interesting to look at? And the answer is yes. There is many other things about the aging of this satellite that are very interesting. But yeah, radio amateurs still listen to it on a daily basis, still forward the data. I don't know at the moment, maybe Chris can tell if there is still thesis work going on analyzing the data, but I do remember that they have, for instance, shown the influence of the tilting of Earth axis on the temperatures over several years.
Yeah, they could determine very accurately the orbit of the Earth around the Sun based on the temperature measured by Delfi-C3.
Yes. So those things, like there is all that data is available for people to look at and analyze. So yeah, there is potentially a lot more to learn from this mission.
Yeah, there could be done much more with the data. I can remember when the day after the successful launch, we were sitting together with something like, now what? Nobody thought that we should have a team to do something with the data. We were so focused on getting it launched that we never thought about the day after the launch.
Well, actually, just to check on what Chris just mentioned, most of the infrastructure is still very much the same as it was a long time ago, and in that sense, keeping it alive is an interesting challenge. But yeah, as Wouter mentioned, we get regularly data from Japan. There's a couple of people from South America. There's other people from Northern Europe that actually receive it on a daily basis. And all the data gets submitted back to the central repository, which the university is hosting, and we can just collect this data and analyze them.
I also see a question about Lunar Zebra and what lessons we learned from Delfi-C3 with respect to Lunar Zebra. And there are, say, technical and non-technical lessons learned. The non-technical one is what I believe is when you build it, it goes to space. So we were convinced when Delfi-C3 is ready, it will go to space. Totally convinced. And I have the same thing with the Lunar Zebra. Of course, it is a project that is unrealistic, like Delfi-C3 was unrealistic, and the students can't do it, like the students couldn't do Delfi-C3, and the technology was not up to it, like the technology was not up to it with Delfi-C3, so all the same and the same. But still, once we built it, it went to space. You see with the Pocket Cube the same thing. Now it's on the table and it goes to space. And I have the same thing. If the Lunar Zebra is ready, it goes to space. So that is one thing I learned to keep up the spirit. Another thing that I learned is when you talk about it, do something with it. I can remember that we had 2 transponders in the satellite. and one of the transponders was unstable. And whatever we did, we couldn't find the cause. So, and it was unstable in a part where you wouldn't expect instability, yeah? So oscillations, but it was there. So finally, what we said, just let's turn off that transponder because we have one. And then I was talking with I think with Wouter Jan Ubbels about the fact if we solder one wire from the receiver that doesn't have a transponder anymore to the other side, then at least the transponder we have left has two receivers. And then we said, I'm not doing that. Yeah, and then what happened is that the receiver that was servicing the transponder broke down. And if we had soldered the wire, we would still have had a transponder. So if there's one thing we regret is 5 minutes of soldering, that would have probably given us a transponder for 12.5 years. So from that, I learned, if you talk about it, shouldn't we do this? Shouldn't we do that? You do it.
Fantastic. Thank you so much for so far. We're going to go on a short break for a little bit. We'll be back in 10 minutes and we'll continue with more questions and more information about Delfi-C3. And we'll keep this up and more fun. Yay.
Okay, see you.
Thank you. how it helped you, how it helped you with the other things that you were working on at the time, or those who were working on it, maybe Wouter, maybe you were working on something. I mean,
I can't
it helped
remember
you.
was doing anything
And-
else.
No,
What?
I think I was, yeah, mainly working on Delfi-C3 and trying to also study at the same time. But when you have the opportunity to look at linear algebra or calculus or engineering satellites, I think we know what's going to lose. So yeah, it was really the team and building the satellite that was the main focus. Um, at that time, yeah, I think it was all hands on deck. It has helped me a lot in my career later, but you don't realize that until you're done and the thing is flying in space. You're just like focused.
And I think that every electrical engineer that is Delphi veteran values systems engineering.
That is also true. And I must say that also getting to know Rob Haman, who was also teaching that course at TU Delft, has definitely opened my eyes as an electrical engineer. Seeing that, oh yeah, there are people that are specialized in looking at the big picture, and they are not necessarily interested in how you exactly solder a resistor to a board, but they are interested in all those things that normally get forgotten when when you make something.
So now the students that are doing microelectronics, so in electrical engineering, they have a compulsory course systems engineering in the master phase, and basically that is because of the Delfi-C3 experience. I think even Georgie knows the world now.
Actually, Chris, I knew the world before that because, as you remember, I did spend quite some years before TU Delft at the industry, and we are working on some
Yeah, I
safety
know.
critical systems. But indeed, the system engineering education, especially at the electrical engineering, computer engineering, computer science programs at the university was not there, and some of them is still not. And we had this recent discussion, which was, of course, related to the ZIVO, and we hear the same problem that all the other subcomponents, including the electronics, they can be managed, and the software seems to be like this unmanageable thing that can never be predicted how long it will take to make and deliver. And yeah, we kind of concluded that a little bit of system engineering approach and methodology would be quite helpful.
So, from what I understood, that there are some companies that became a spinoff from Delfi-C3. Can you explain us a little bit more about those companies and what they're doing and how they're well, proceeding with that project?
Yeah, I see two names, ISIS and T- in the question in the chat. But there's, for example, also the company Hyperion that also has a direct Delfi-C3 relation. There was a company called Systematic Design that still exists, that started cooperating with the Delphi project and gave us a lot of help. And that company spun out Hyperion, that totally focus on space issues. And Hyperion is also really building electronics and so on. So but now they have grown up and built satellites and so on. So there's quite some companies that actually came from it. And yeah, then you get the whole environment. There was quite some money available because of the MESAT project we had. And that made that we could also say sponsor rocketry that we like to do. And that's how you got, say, the T minus there, and from there you got the Dawn Aerospace. So if you look around, then a lot of how do you call it, small space industry has started in the Netherlands because of the ecosystem that Delfi-C3 created.
Is also Pocket Cube just are there companies also spun off from Pocket Cube that are out there, or will there be any?
Yes, well, there are already some existing companies that were built around the idea of pocket cubes, especially one in UK, which is the one that we are collaborating the most for the launch of Delfi-PQ, called Alba Orbital. And they are also developing the deployer, which is very important for a satellite to be launched in space. Same as for CubeSat, same for pocket cubes. But at the moment, we are not experiencing in Delft, in the Netherlands, the same. So pocket cubes are still in a very pioneering phase, and we know that it will take time for developing, a business case for companies to be built. And the application of pocket cubes is really the strength, the power of a pocket cube is when you deploy it in a swarm of satellites. So the idea is having many of them, and to be launched with a higher frequency of launch, so that you really have a constellation of very small satellites that can, for example, sample the density of the atmosphere or the space weather conditions. So these are the application that we have in mind, but it's a long way, and we are very happy because we managed to build the first one. The future will be really demonstrating the swarming capability of pocket cubes.
But there is one potentially very exciting science experiment on board, because it's flying a radio receiver for radio astronomy, for low frequency radio astronomy, that could do serious measurements. So I really hope it works, and then it can give us valuable data about interference that you measure over there. So it will not do radio astronomy by itself, but if the system works, then the next step would be have the 2 or 3 of them start doing interferometrics. And then you can imagine that you can have something like these little satellites further away. Just take a bunch of them, deploy them, and you build yourself an interferometer. So it is, as you say, swarming large numbers. That is what they should do.
Yeah, I think it's also interesting to see how long that has already been sort of the focus, because I remember having a discussion with you, Chris, during the design of Delfi-C3 already about those radio receivers. So this is all like long-term planning.
With Wim Jonkind, I had a paper in 2003 about the satellites as a swarm. Then we called it a colony. We didn't think of the word swarm yet, but we said satellite colony. Thinking of the ants that form a colony, and then you had the radio telescope LOFAR. So there was a huge example of a radio telescope that is built of many different antennas. So if you want to do that in space, there's no alternative than doing it with small satellites, because you cannot launch enough big satellites. There was an ESA study, DARIS, that was 5 or 6 big satellites to do interferometrics in moon orbit. But it was also clear that it showed, it was a science case, it worked, but it also showed that it was not affordable to do that. Yeah, and then the nanosatellites came, and now suddenly it seems affordable. So then if we get it done, then the descendants of Delfi-C3 will form a radio telescope around the moon, and that's then called LOFAR. So the anagram of LOFAR. So the ultimate science instrument. At first it looked like science fiction, but now it seems doable. I think now it's a matter of money, not a matter of technology.
Imagining something that you can make it, and then, well, imagination is the first step to making something amazing. At least that's my opinion on anything, basically.
Yeah, that's true. There's this musical South Pacific where they sing a song where they say if you never have a dream, you will never have a dream come true.
There we go. So, well, the Pocket Cube is being launched in December. What are the next steps that are gonna follow for that after its launch? And how long do you expect for it actually to survive out there? Well, I mean, the C3 was not really expected to last 12 years, from what I understood, but it is, and it's still going strong. So for Pocket Cube, what is the expectations on that, and what's the next project that follows it?
Well, in terms of a lifetime, that's a big question because I think we will face something similar to CubeSats. So either it will fail immediately, so what we call the infant mortality of satellites, or maybe it will survive longer. But being on a low Earth orbit, it will decay after some time. So we expect it to get it back in about 3 years.
Well, currently it's in the same orbit as Delfi-C3, so when they will decay, they will probably decay almost together.
Yeah, that would be very cool indeed. We should take a picture. And regarding the next plans, it's a little bit it's still to be seen. As I said, we really want to fly more together, so to demonstrate the constellation, the swarming concept. Yeah, we are not starting to prepare for that yet. We will focus on the operations, of course, because we want to learn about this first iteration of Pocket Cube as much as possible. So we will get all the telemetry and analyze them in order to understand exactly what kind of reliability we have there.
Well, you can see it maybe as Delfi-C3 because back in the days, there were not that many components that were existing on the market, very few. The team had to build almost everything. And now, by shrinking everything by a factor 2, we had to build again everything from scratch because almost no component was available on the market. So for now, it's again first time and to see if this all works together.
Yeah, and it's a factor 2 in all axes, so it's more.
It's a factor 8 in volume, which is tricky. It's also a factor, well, almost 8 in mass. So in that sense, thermally, it's way worse because bigger satellites, bigger CubeSats, still because of the sun, their temperature swings quite a lot in space. But ours is almost in the full operating range of the electronics, 15 times a day. So stresses are gonna be a lot harsher now.
What are the sensors that are used on Pocket Cube?
Well, it's very similar to Delfi-C3 in that sense, as a logic, as a structure, and most of the satellites have a very similar, we can say, architecture. But what is very common to everybody, as Chris mentioned, temperatures. We could use temperatures as this is a very important parameter because it tells you if everything works correctly. And it also tells you basically how much energy you're receiving from the sun and how much you are radiating. So this is an important one. The other ones, well, mostly monitor the status of the platform. And so this is more just to know if the satellite is working, not related to the sort of end goal. As in Delfi-C3, they were also monitoring instruments, like, for example, the sun sensor, which was measuring the angles at which the satellite was seeing the sun in a new way. We won't have any sun sensor. We have a sensor, as Chris described, that will monitor the low frequency spectrum. And of course, we're not going to be able to do radio astronomy with it. We're just too small. We don't have meters and meters of antennas. We will only monitor basically the noise that us humans are emitting in the space.
I think maybe the satellite would be able to do radio astronomy if it were in moon orbit. but unfortunately it isn't. But we also always said that it's impossible to do the radio astronomy in Earth orbit because of interference, but there are not so many measurements in those orbits actually. So in that sense, it's interesting to know what's going on there.
No, that's definitely an interesting science case for us. And then we have this first time for the instrument, which, well, if you really look at the size, it's sort of few centimeters thick. So this is the size of the complete instrument, 4 by 4 centimeters, and not even a centimeter in thickness. So it's not even 100 grams in total. So it was fairly challenging to basically push everything in there.
So, what were the similarities for developing right now? You just said that there were some things that was kind of like Delfi-C3. What were the similarities that, well, it actually inspired you from that to
Well,
create?
one of the things which, well, it was very similar, but we decided to go completely the opposite way was the battery, as it was already mentioned, because we actually wanted to try and see if we could survive for the whole orbit. And also because of the payloads we were carrying on board, well, it's very interesting to do, to measure, for example, the Earth emissions in low frequencies, also when there is no sun. While in Delfi-C3, the science case was clearly not there. There was no need for a battery.
Yeah, we were
Like-
testing solar cells and a sun sensor. So what's the point of a sun sensor when there is no sun?
So in that sense, we try to do kind of the opposite to try and see if we could use it as well in the darkness. Satellite structure, if you open up Delfi-C3 and open up Delfi-PQ, they're very much the same. There's just a big stack of boards all on top of each other, which basically allowed us to play quite a lot the system engineering game, because every system has been kind of confined into a single board, into a single volume, so we could develop them all completely separate. And simply iterate on the design of a single system while the rest of the spacecraft remained the same. And this was definitely the same philosophy in Delfi-C3. You see a lot of subsystems in there, all dedicated to a very simple functionality, which is also nice for students because basically every student gets his own package, and it's his own package. Ownership is important to get the motivation.
How many students were involved in Delphi Pocket Cube?
Whoa, that's a tough question, to be fair. We have been counting. The number, we don't have it. It's definitely a smaller number with respect to Delfi-C3. One of the reasons is that there's a lot of other projects in there. So now, back in the Delfi-C3 days, this was the only satellite project where satellites were being built. Now it's becoming more common, so students also choose which one they prefer the most. So in that sense, that was, for example, Delfi-C3 used a lot of master students, while in this round, we couldn't really focus so much on master theses. One of the things we managed in this project was to try and push it a little bit more towards the general education. So in a course, you have a lot of students that can participate. Of course, they'll all do a smaller piece rather than the full system. They will work on a smaller piece, but then numbers could increase. So it's a nice, very nice discussion, but I don't really have a number just to answer fully your question.
Yeah, but
But,
I would say if they were in the range of let's say working not for an assignment but for a little longer, where about 10 students in 3 years, something like that, I would say.
are they all master students or also bachelor students doing their thesis on helping out, or is it just, does it go to there or higher than that for education?
Yeah, they were mainly master students, but we had also bachelor students, and we also have had internships, for example, from HBO, from Hogeschool. Yeah, there was involvement, a bit more variation with respect to Delfi-C3.
And what about Delphi Next? That one was between these two projects. What about that? How did the process for that one go? You know, or what it involved?
Yeah, it was basically Delphi. Say we wanted to go on from Delfi-C3, but I think in the beginning we became over ambitious. I remember there were two parties. One group said let's morph Delfi-C3 to something a bit more complex, like put attitude control in there, and there was another group that said, well, let's put much more in there. So there was a mass spectrometer, or what was it? There were quite some instruments in there, so it became very complex, and then in the end, of course, we couldn't have that instrument and so on. So but
What
it
is
was
actually, sorry, what is actually the difference between Delfi-C3, Delphi Next, and Delphi
Delphi
Pocket
Next.
Cube?
Delphi Next had attitude control,
Okay.
so that was the major next step.
Yeah,
And
and
Pocket,
some of the
And
subsystems.
actually Delphi-C3 also had attitude control, but it was passive with magnets and hysteresis rods. So it had some, and that worked amazingly good. Actually, we had absolutely no experience with it, so it was a guess, but it did work. But Delphi Next had active attitude control.
and Pocket Cube, what's the different? What does it have additional things compared to Delphi-C3, or is it completely different? Just all the similarities that you mentioned.
Well, I think we discussed it already. It is completely different in the sense that is a different form factor, is much smaller, and that was the main challenge because everything was needed to be designed from scratch. That was the main thing. And in terms of complexity, we are going towards a much simpler design, of course, but because we want to demonstrate the critical subsystems to be successfully launched in space.
We tried as well an attitude control system, just to add on that, but it's something a bit of a step in between what happened in Delfi-C3 and what happened in Delphi Next, in the sense that not having a payload which actually needs accurate pointing down to Earth, for example, to take high resolution pictures, we didn't really need a high precision system that would point. That also allowed us to simplify the design.
Thank you. So right now, you all have much experience about this, and what are the good things, bad things, the whole process that goes on for it. What advice would you give the students who want to join the team, or they want to be able to participate in here, or they're thinking about it, or they are already participating? What advice would you give them that they could do better, or think about, or broaden their horizon?
Yeah, in my opinion, one of the very good thing is multidisciplinary, because we are seeing that a multidisciplinary approach is really helping also in developing spacecraft. So also Chris mentioned it. I think that one of the key factor for the success of Delfi-C3 was that for the first time, electrical engineering and aerospace engineering were coming together. But for the challenges that we face in Delphi PQ, it would be beneficial also, for example, to have a mechanical engineer. That is something that we didn't manage to get in board because we don't have the right connection. I mean, definitely the message is that there is not a discipline that is not good for working on a satellite. Actually, any student from any engineering background is welcome, and his contribution or her contribution will be very much appreciated.
Yeah, and I would say everything is impossible until it's done. So believe that, and I also have an attitude that maybe you know the movie Dumb and Dumber, when Jim Carrey asks a girl, "Is there a chance that you'll go out with me?" And then she says, "Well, 1 in a million." And then he says, "So I have a chance." So look at that. If there is a chance that it works, go for it. So don't go on a project for warp drive or something like that. But if it's remotely feasible, then yeah, you need people that go for it and build it, and then the rest will follow. So if you believe your rocket can fly, build it and show it flies. And if people don't believe you, yeah, show it, put it on the table. Same with Pocket Cube. Pocket Cube is nonsense until it flies, and then the world is different. And I remember we said the same thing with Delfi-C3. Everybody thought that was a stupid thing, an instant space debris. But we all said to each other, the day after the launch, when it works, will be then it will be a different world. And I can remember that quite soon after that, we got an invitation from ESA to come to ESTEC with the flight spare to show what we did. Because it was unbelievable that the thing was in space and was working. So I don't think we could have had the same appointment 1 month before the launch.
Yeah, I definitely agree with that because I've had a similar experience with a 1-unit CubeSat because we went from 3U, which is Delfi-C3, that's 10 by 10 by 30 centimeters spacecraft, and I designed a 1U CubeSat, so that's 10 by 10 by 10. And the same thing happened. They basically wanted to see like, oh, it now fits into 1 cube. How does that work? And yeah, there's a lot of people that always look at you, and I'm sure that Chris, you have the same experience when you hold up the satellite, or in this case, the flight spare or an engineering model. They're also like, how big is it in real life? And you're like, this is it. I can turn it on. It works.
Yeah,
and
we had the same experience with the Lunar Zebra. That people see it and they say, and how big is the real one? And now this is the real one.
Yes, and I'm pretty sure that with the Pocket Cube it will be the same. If you hold a Pocket Cube, like what is this? Like it just doesn't compute as a spacecraft until it's there.
Yeah, they say, are you still using an old phone like that? No, it's a satellite. Yeah.
Yeah, exactly.
Well, you start to see all the teams also sort of comparing their satellites with weird stuff, like, oh yeah, Delfi-C3 is a milk cart.
Have you ever seen a milk carton of that size? I don't think
know.
so.
But yeah,
but if you look at it, and I have it here, then you can see the Delfi-C3 perhaps could have been Delfi-C2. Because there was some misunderstanding in the beginning. That if you here look at it, you can see there's an enormous amount of space between the PCBs, and then you can ask yourself how come. And that is because in the beginning the system engineers asked the electrical engineering guys, how high will your board be? And I remember we all started looking for the highest component we might ever use, and we gave that number. And then in the end, we never used the component. So actually, they should have told us, you have no more than half a centimeter, and then probably we would have fitted it in. So that is also one of the lessons learned, that you get what you ask for, and if you're not asking for it, you're not getting it. So that's why we have so much space.
Yeah, luckily, because it did make things a lot simpler.
Yeah, that's.
Well, we saw the challenge when we were integrating Delfi-PQ. Yeah, try to stick, well, a CubeSat is 10 centimeters. Fingers, yeah, fit fairly easily in there. We had the problem when you halve everything, well, actually, yeah, they don't fit anymore.
No.
So in that sense, yeah, the smaller you make it, the more complexity you get, because it's also very hard to handle.
But of course, when we were building Delfi-C3, we knew that if it would not work, it would be the end of the whole research. So we also said, let's not take a risk. So the battery was one, but for example, with the radios and so on, we said, let's not do exciting things or exotic things. Or the radio has to work. So actually, that's why the radio was basically built by HBO engineers, and not by TU Delft engineers. Because we said, we don't want something fancy that nearly works. We want something that just works without compromise. And then if you need engineers that can do that, then well, we found them. Wouter was one of them. Just no nonsense. Make something that works. And now it works for 12.5 years. So we always said, keep it simple, stupid. So a well-known phrase. And that makes, I want to share maybe one picture with you, and it is this one. This is Delfi-C3, the outer side, and there you see down here, you see this orange thing, and that is actually a piece of artwork. Because there was an artist that wanted to be the first artist with art in space. and then he heard about keep it simple, stupid, KISS. So then he designed this piece of art. So this is a kiss to the world, and that is on Delfi-C3. So keep it simple, stupid to the full. And I'm glad we did that, because if the first satellite would not have worked, everybody would have said, told you so. And then I would have to go back to designing chips in the cubicle and Wouter working on telephone appliances and so on. So I'm happy it worked, and I'm happy we kept it simple. It doesn't matter if the second one doesn't work. The first one has to work. So the same for the Pocket Cube. It doesn't matter what happens with the second one you launch. This one has to work.
So
Just a little bit of pressure.
Yes, no pressure at all.
No pressure at
Oh,
all
no.
in this moment.
I want to add, by the way, to the thing that Chris said, and Alessandra, you also already said this, that it's really important to have a team of multiple disciplines, but also education levels. We also in Delfi-C3 had a lot of different students, including students that are soldering stuff or just very good in creating PCBs, which are typically not university students that do these things. And yeah, in Delfi-C3, we also found that we needed all those disciplines, but also all those education levels. Students at the university tend to have the idea like, oh yeah, we know how to do things, but practically sometimes you just need an expert.
Yeah.
And that also holds for people with experience. We had a veteran of Dutch Space soldering our boards. And he had, at that time, I think 30 years experience probably soldering boards in the space industry. And he taught us a lot of things. And he was also saying, oh, you young people, oh, you don't know how to do this. But we learned a lot from that. And it's really important that you also have all those people in the project, and not just master students that are used to high-level designs, but actually haven't built anything.
Yeah, I think Dirk was such a relaxed and quiet person that you could set off fireworks and then still he would solder the component. And he was very precise. Every component that he would put on the board, he would measure it to make sure that it was the correct one. And there he also saved quite some some errors, I think.
Oh yes, and I pestered him a lot. I had almost daily changes for him. Okay, here we have a picture of Dirk.
A picture of Dirk, yeah. So this
you had to bring enough coffee.
This is how people remember him, staring in the microscope and putting the components there.
Yep.
But I also remember we got a soldering course of Johan Leitens. And he took, I think, 1 day to teach me that in the morning I thought I know how to solder. And gradually I learned I didn't. And at the end of the day, there's a lot of things that I learned from him that I'm still using today. So even something seemingly simple as soldering, you need to get an expert telling you what to do and what not to do. Even the way you cut off the wires of a resistor can be disastrous if you have the wrong type of pliers.
Johan is watching the live stream, by the way. He says, leuk om te horen.
Yeah, there are things that he really can do very well.
Well, I wanted to also ask if you were to do it differently for the Delfi-C3, what would you do differently? What would you not do that you've done during that process? Or what would you just change completely?
The only thing is I would have soldered the wire for the transponder. That I would definitely have done different. And maybe the other thing is we would have read the manuals of the processors, because the Delfi-C3 has a tendency to get the IQ2 bus in an hang up, and then it has to reboot. And we have spent weeks trying to find out what software error or what EMC problem was the cause of it. But finally, the cause was that we had the power picks that just did the power control of the boards at 32 kilohertz clock, and the rest at 1 megahertz or something like that. And somewhere at page 250 in the manual of the processor, it says you shouldn't do that because then the picks at 32 kilohertz are too slow and they hang up the bus. So we built it in, but yeah, we only read the manual after the satellite was launched. So that's the thing. Read the manual.
It's a rather big manual as well.
Yeah. So it was not a bug. It was not EMC. It was just something we were not supposed to do.
This is also one of the things that comes up a lot when people ask about Delfi-C3, because I2C Buzz has a unreliable track record, which is not true. It's basically very reliable if you do what the designers of the bus tell you to do. But being students, obviously, we scan through the manual and just start working. And yeah, we never properly found that and tested that before launch. I think apart from that wire, I would say more testing time on the software. I would say that would have saved us a lot. But other than that, I think it went pretty good, and it's still working. So.
Yeah. For 12.5 years, it's advertising. Those guys didn't read the manual. Yeah.
Yeah.
What about
Actually,
for
is there anybody in any other space project that wouldn't say test the software more? Because I think it's the common problem.
Yeah. So one of the projects I'm involved in, FunCube, we tested the software to death almost, and that is the only project that I am willing to say sufficiently tested the software. We found one bug after launch that is not influencing the satellite at all. So it's a bug that doesn't affect anything, and for the rest, that is pretty good. But that is a full year of software testing.
wow? Yeah, that's intense testing. What about for Pocket Cube? That well, you're about to launch it, so I'm guessing the project, everything is wrapping up. If there were something to make it different, what would you make it different?
Oh, that's a good question. I mean, of course, we faced a very peculiar situation with the COVID, and that made things very different, very difficult. So, I mean, if I would have a magic word to cancel the COVID, that would be it for our experience. But yeah, in general, indeed, the testing is something that it is it's always left to the last moment, to the integration phase, and it would be nice to accumulate more time for it. And I would write more documentation, but this is a bit of a fight in the team, right, Stefano?
Well, in the end, we really faced with COVID hitting the university. The number of people that were allowed to be on campus was like few in the building. We basically jammed all the slots available for the space department. Nobody else could go to the campus because we were basically using the office. So in that sense, the team was reduced to the bare minimum. Everything had to be debugged with people far away. Uh, Imagine some of the students, well, after a long time in lockdown, they couldn't really stay in the Netherlands being foreigners. They basically went back home. So you start to have people talking to you that did some parts of the project that are actually, for example, in China or in other countries. So you start to have time zone issues. And in that sense, development basically slows down tremendously. And there, really, we just scratched everything we could really scratch out to be able to finish. And in that sense, we're proud that we have finished. We, as kind of most of the space projects I was involved so far, well, the day of the final environmental testing, comes and you probably spend the night putting the last bolts and putting thread lock on those bolts. And yes, we've been there. Definitely. That's something everybody wants to say, no, I'm not going to do it. And you almost always end up in that situation.
And the last of the flight software is written in the airplane to the launch base.
Yeah, kind of.
But in that sense, we try to learn from that. So we spent quite a lot of time actually working on in-flight software update, which is a fancy feature, which is where a lot of the testing actually ended up. And we are super glad we managed to do that testing like 6 months in advance. Still, the day of the integration, we still found one bug which we haven't fixed yet. But yeah, we'll see. We'll in 2 months we'll let you know if we manage to fix it in space.
Well, we have one last question, and that is that what is each of your favorite memories? So each person, one favorite memory on the project, fun, happy, or challenging day that you had, but it's just the only memory that is always with you and you always take it with you. What's that memory?
Yeah, for me it was when Delfi-C3 was launched, the second pass. So we didn't hear anything in the first pass, and we told ourselves, well, hundreds of reasons for it, but we also didn't hear it in the second pass, just listening to noise. And then I felt really desperate. Years of work down the drain, so I was already finding excuses, and then it came so loud out of the speaker the next pass that I still remember how I felt there, and the relief. It's also one of the few occasions that I didn't know what to say. I was completely silent, and just that was it. So it's one of the best moments of my life, especially because in two passes we thought it was all for nothing. So that really made us feel great in the third pass. And I think Wouter Weckelaar, you have the same feeling.
I was going to say my memory is almost the same, or my favorite memory. It's launch day in general, but the fact that I think it's not one specific thing, but launch day as a concept in the morning, all coming together super early in the morning to watch the launch, and seeing on a television the rocket go up from India, knowing that you've seen it launch and you've seen it on the ground as well, and a couple of hours later listening to a signal from space, and the same day where we actually, when we were a bit more relaxed about it working, I went on the roof of the electrical engineering, so not in the ground station, but really on the roof, with a portable antenna. And the feeling that you get when you hold this antenna and you find the strongest signal, and you know that if you look down the antenna, you're actually looking into the void, knowing that something you built is exactly where you're pointing that stick at. And I think that is, for me, and it still is, if I hear the satellite and I have a handheld antenna and I can find it in the sky, knowing that a small box somewhere there is there talking to us. And I think that's amazing. And that was the first time on launch day that happened. And yeah, I think that's going to be my favorite memory for a long time, not even from this project, but in general.
So yes, indeed, in accordance to what was just said, when we start receiving the data from the satellite, then this was really great because this was really the purpose. This was the main functionality that was composed by all these subsystems and all these pieces of software. And yeah, this was just great that all of this was working.
Yeah, so you should really look at the movie on YouTube of the first reception, because that totally tells what happened there. You see the tension of listening and expecting it. And then if you see the face of Wouter Jan Ubbels, I don't think you can see a happier face than you see over there. Also, that's a real funny anecdote that actually Wouter Weggelaar was the first person to receive a frame of Delfi-C3, but Wouter was at the backup station. So when you listen carefully to the video, you hear Wouter shout, "Ik heb er een." So that means he got the frame and nobody listens to him. And then from the main station, the telemetry comes, and then we say we have our first reception. But actually, the honor, I think, goes to Wouter Weggelaar of the first frame. And then you see everybody pretty relaxed, yeah.
It was interesting. I also later realized why that was, because the first frame was actually an experiment frame, which contained a solar cell curve. So it did not contain the deployment status of the antennas. And that's what we were looking at. So we were waiting for something else to change in the screen. And I noticed that I got something, but I didn't see the numbers fill in because it was something else. And I was very much concentrating at that time. And you can also see the difference between the operators there. And yeah, it was interesting. It was really, really something.
So it also tells everybody when you launch a satellite, be in the ground station. Mission control or the press or whatever, not interesting. If you want to have direct contact with your satellite, be in the ground station, and then you really hear your satellite. The rest is just for show.
Thanks, Chris. We will take into account. Hopefully,
Yeah,
we will have the same moment.
when the launch is there, be in the ground station.
We hope we can have these nice memories. Not yet there.
Well, I'm sure that you already have some great memories while working on the project. Do you have any one to share?
Yeah, well, there are no moments like the ones that were said by the Delfi-C3 pioneers, because we have, yeah, the launch is indeed the experience. You know, I had it in my past experience, and this is what we are looking for. But in general, I think the last months facing the COVID-19. It was really nice to see, you know, the commitment of the team and how motivated the people, this small team was to get it done. I think that was really nice and warming.
Well, just to add something on that, it was tight. We definitely had a tight deadline, and we started aiming at, well, we don't know we're gonna make it. We started aiming at the test. This is our goal now. We need to get the first test, and then actually we got there, and it worked. Then we started aiming at the second one. Actually, we got it, and finally we're like, okay, now we can put it in a box and ship it. So in that sense, I think we've been aiming at the vibration test. That was one of the nicest moments. Yeah, let's see. Our goal is now to make the vibration test. If we make it, we're probably good. And then once actually the satellite came out of it alive, we're like, actually, we can actually launch it. I was a bit like, ah.
Yeah, somehow you're always surprised, even though you engineered it to survive. You're always like, oh, it actually did. And it shouldn't be a surprise, but it always is.
It comes with also a lot of stress in the last period. So it's like, yes.
Yeah,
Well,
and the other thing I remember is the team. So it's so good to be in a team of people working on the same thing. That life at the university can be very lonely if you have to do your own research, write your own papers, write your own proposal. So then being in a team doing something like this that's where I want to be. So I'm very happy that always was possible for me.
Well, thank you everyone. Thank you for our lovely speakers, for all these amazing stories that you told us and about the making of Delfi-C3 and also Delphi Pocket Cube, and I really, really hope that you'll be able to see Delphi Pocket Cube launch and have the same experience and amazing feeling that they had during the launch of Delfi-C3. Um, thank you very much, Jillian.
Yes, thank you to our speakers for telling us your stories. It was definitely insightful and inspiring, especially for me who's working on Lunar Zero right now. Good tips from you guys. Do enough testing, do documentation. So I hope any of our team members that are watching take those into account. And yeah, it was great hearing from you guys. Thank you so much for being our speakers tonight. And thank you especially to Azita for being a great host. And thank you to our audience for watching our event. If you'd like to follow more of our events, you know where to find us. Join our community on Discord and follow us on our socials. And yeah, thank you everyone for being here.
Thanks for having me.
Yeah,
Thanks,
thank you.
everybody.
Yeah, thank you. It was great.
Thanks for the organization. Thanks.
Thank you.
Thank you.